Hopefully I have enough memory on my phone. Okay. So I'm going to go over some of the kind of basic way, maybe the basic way to start drawing these axonometrics. So I guess just to set context, this is pretty much what our drawings are going to look like. But we will have an extra axonometric. So this guy will slide over a little bit and we'll get that other axonometric from the complete opposite side of the thing drawn there. There's a layout that Stephanie drew and posted on the wall over here. Please look at that. It's got some kind of border dimensions for you labeled on there and stuff. So that should work. There's still some math you're gonna have to do, but and then this sheet is for our just measurements of the chair. Yes, there is not a top view, there's not a plan view of this thing, but every dimension on here should lead you to be able to draw that top view of the thing. Kind of like we can draw a side view of a thing using a top view, we can also draw a top view of a thing using the side views. Just kind of in the opposite way. I would, before I even start doing anything, I would just go onto Google and find some photos of this chair. It'll help you just kind of wrap your mind around it a little bit, kind of understand what you're trying to draw. Okay, so what I'm gonna do for you guys, I'm gonna show you how to kind of start mapping the thing out and start the first kind of elements that you might draw. And then I'm going to show you how to draw one of these elements that's kind of hovering up in the air using a kind of coordinate system type of thing. So I think rule number one with axons, or thing number one to think about, you will set your triangle to 30-60, your adjustable triangle to 30-60, and you will not reset it to any other number for any reason at all. This entire axonometric drawing will be drawn with 30-60. If you ever have to adjust your triangle to draw something, you're doing something wrong. Something's going wrong. Besides these angled bits, but everything that is straight up and down, straight left and right on this axon will be drawn with a 30-60 triangle.
Or if you have a 30-60 triangle.
Yes.
You're good to go.
Yes. As a matter of, yeah. 30-60 triangle, you can draw this whole thing. Okay, so where I'm gonna start with this thing, and where I maybe recommend that you guys start too, is by looking at this sheet and getting the kind of dimensions of the chair as it sits on the ground. So what are those numbers? It is 3'6" and a quarter, kind of deep, and 3 foot 4 inches wide. So I'm gonna start by drawing a box that is 3'6" and a quarter by 3 foot 4. And this will be kind of my ground. This will be where the chair is sitting, the surface of the ground. So let's get my scale. We're drawing at 3/4 inch equals 1 foot scale. So I'm flipping to 3/4 inch scale. And what's that? Zoom out? Oh, up here. Okay. Okay, so 3/4 of an inch scale. So I need 3 foot 6 inches and a quarter. So I'm gonna say that I'm gonna start this axon here. It's gonna be kind of my front corner of the thing. By the way, these drawings are going to get really tall. They're gonna get taller than you expect. But 3'6". So my 6 inches is that middle line and a quarter. And I will make a dot at 3. So now I've got that dimension figured out. I'll go ahead and draw that line. I'll draw them extra dark, but just so we can see them, but this is should be a construction line. And then we'll go over this way, 3'4". So that was with my 60. Now I'm gonna flip to my 30 so I can get a right angle here. 3 feet 4 inches. So there's 6, there's 5, there's 4, and 3. Mark there. So a thing with axonometric drawings, a thing that's probably going to happen to people, a lot like when we project, you know, like the floor plan down to the elevation or whatever, every time you're kind of off by 0.5 millimeter, you know, you're off a little bit when your pencil's, you know, touching the one thing and you project it over, and then you're off a little bit where you make contact and bring it down, you're off a little bit, and then you get down to the bottom and it's like way off. That really happens with axonometrics. You'll kind of like measure the thing here, you bring it up, you bring it over, you bring it across, you bring it down, and then it's like 1/2 inch off. So it's extremely important to be super accurate as possible with making sure you're lining up at the measurements and kind of being super cautious with the way that you're building the thing. So I've got the front 2 edges of the kind of box that this whole thing is going to fit in. So now I'm just going to switch back to my 60 to hit that point there. I guess you can actually see that. And I'll switch to my 30 where I measured that point and go here. So now this is the box that the whole thing will fit in. Again, this is 3'6" and 1/4 inches. And this is 3 foot 4 inches. And I got that from the paper. Okay. I'm gonna draw the 4 kind of corners of this thing now, the 4 legs that are holding the thing up. 1, 2, 3, 4. Well, 1, 2, 3. But I'll draw the 4 legs kind of going upwards. So those are all 1 3/4 inch, and they're different in height from front to back. So start by drawing a 1 3/4 inch little leg here. My 1 inch scale. It's gonna be super tiny. There's 1 3/4 inch. 1 3/4 inch. And now I can finish out that square just by using my 30-60 triangle. Kind of X-ray vision through the thing. I can use construction lines to bring that across to where it'll hit over here. And then I've got to measure this thing. And I'm using my 60 to make that square. Okay. So now I've got the 2 front legs kind of marked on the front side of this chair. Maybe I'll just do those 2 front legs. So here's those 2 front legs marked kind of on on the ground on this thing. Now I need to know the height of those two front legs, which looks like it's 1 foot 11 inches from the bottom of that leg to the top of that leg.
I'm a mother and I have
That was a fun jingle.
pets.
It's good to break the monotony.
I defend my right to have my.
So 1 foot 11 inches is what I got over here. So let's go 1 foot 11. So 1 foot and the last inch mark on there. Make a mark there. And I can actually use my triangle so I don't have to measure another line up there. I can just use my triangle to bring that over. I know where this point intersects will also now be 1 foot 11. And that will be 1 foot 11. And this will be 1 foot 11. And then I will be able to draw this back corner up, kind of just a construction line for right now. Back corner up, just a construction line for now. And use my 60-degree triangle. Where that contacts there, I know that that's 1 foot 11. So you can think, I like to explain this like you can kind of find a measurement and then it's like you can wrap a belt around the object. So I'm wrapping a belt at 1 foot 11 around the object. If I wanted to make a 1 foot 11 mark around this entire prism, I can just use my triangle to kind of make this belt around the thing. Now at that intersection, can keep on wrapping that belt around. There's that intersection. And if everything is drawn right and you are perfectly kind of measured up, this last line here should match up perfectly. This is where you'll start to see kind of what I was saying, where like you get off a little bit there, you're off a little bit there, you're off a little bit there. Then when you kind of bring it around town all the way to meet back up, this will be like 1/4 of an inch off. And that's kind of like, okay, it's because you were inaccurate with where you had it meet there, where you had it meet there, where you had it meet there. Then when it all matters, you're off. But again, I only measured 1 foot 11 once, and I wrapped that belt around that object. Okay, so we can cap these little pegs. I'm not measuring this at all because I know all my measurements were already made down here. Kind of bringing that 1 inch, 1 3/4 of an inch measurement all the way around that point until it hits that line I brought up. I need to bring up that back corner. I know. And then that front corner. So it was a little bit off because I'm rushing a little bit, but here's those two front pegs drawn. This one, this one. While I'm here, I will say that line weights are important, like we talked about. So I would not do this right now in my process. I would draw the whole thing kind of construction lines and then line weight, but just to get this point in this video, I'll say this is, ooh. Pause. Time to sharpen. Sorry, I just broke my graphite. So I was pushing too hard. That this will be a primary line because we can only see one face that this edge is connected to. Primary line here. Secondary line on that front corner because we can see both faces that the edge is connected to. Or the kind of hand trick, if I put my hand around that edge, I can see both sides of my hand still. Secondary line. This back edge, primary line. Those top two edges, primary lines, which I will not draw for speed's sake. Okay, so there's the front two legs. Now, if we wanted to draw the back two legs, 1 foot, 2 foot 10, 3/4 of an inch, get our thing, measure 2 foot 10, we're gonna start to get those 3/4 inch sticks back there. 1 3/4 sticks back there. And it'll be taller in the back than it is in the front. Okay. Next and last thing I'm gonna show you here, and with these two things, you should be able to build the whole chair, is I'm going to show you how to get this kind of floating stick, this 1 3/4 inch stick that does not sit on the ground surface. How do we build a kind of 3D object that is up in the sky, we'll say, not touching the ground? So to do that, I don't know if you remember in the presentation that we went through, but we talked about how axons are interesting because you can kind of make this like grid world. You can make this like coordinate system. Anybody ever play Battleship?
Yes.
Yeah. It's like you're building this grid system. So you're going over 2 inches, up 4 inches, and then you can start drawing your line. So that's when I'm gonna start showing you kind of how to make a thing hover. So looking at this thing, it looks like that front stick, that front piece of wood, starts at 7 1/4 of an inch above the ground surface. So, and that's the bottom of the stick. This is not dimensioned, you know, how tall is the total thing is not dimensioned, because we know that all of these sticks are always, all these pieces of wood are always 1 3/4 inch by 1 3/4 inch. So this dimension plus 1 3/4 inch equals the top of that thing. 7 1/4. So also overhangs, we'll get to that. Also overhangs a little bit. Actually, that overhang here, can anybody guess what the dimension of that is? 1 3/4 of an inch. Any of these overhangs are always going to be 1 3/4 of an inch. That's kind of the, you know, that's what typical means. It's like that is our, exactly, that's our module. That's our kind of standard dimension in a lot of these areas for this chair specifically. So it overhangs 1 3/4 of an inch. So I'm going to start by marking 1 3/4 of an inch on this line. I know that that's kind of how far out we're going to overhang. I'll go ahead and do it on this side too. Starting from that line, 1 3/4 of an inch. And I will strike this line because I know I'm going to keep on using that kind of 1 3/4 of an inch overhang constantly throughout building this chair. So I might as well mark it on the ground. And we are, the stick is kind of, well, it's not kind of, it is behind that leg. So it's in 1 3/4 of an inch as well. It's not sitting flat, you know, on that kind of outer surface of the thing that we already drew. So it's backwards in there, 1 3/4 of an inch. So I'll go ahead and measure that too. I'm on the wrong scale. One 3/4 of an inch there. Actually, could have just drawn this over to get that dimension. Okay, so this intersection that I just found, which is 1 3/4 of an inch over this way, 1 3/4 of an inch up this way, is where this kind of front edge will sit up in the sky, up in the air a little bit. Specifically up in the air, 7 1/4 of an inch. So I've kind of started this coordinate system. I found that front edge of the thing by going back 1 3/4, up 1 3/4. Now I just from this point have to go upwards into the sky, 7 1/4 of an inch. So this is where, grab my scale again. From 0 to 6, 7 1/4. So now I know that that little mark right there, which will make it a little bit bigger, 7 3/4 is where that kind of edge of the thing will be. I found that by kind of bringing this line up into the sky, 7 3/4 of an inch. This is just a construction line. It's just to kind of bring me up into the air. And from that point, I start to build this thing. So that's my front edge, where this is. Front and bottom edge. I'm gonna go behind that line, behind that stick there, all the way across. I'll go behind here until it hits that coordinate that I found that I'll bring up into the sky. Okay, now there's the bottom front edge of this stick. That is this thing. This thing. So now I've got to go up 1 3/4 of an inch. Lots of 1 3/4 on this project. Up 1 3/4. I'll go ahead and bring that across. And then backwards 1 3/4. Drop this line down until it hits there, and then this line across. Okay, so now I'll finish this side over here too. So now I've got that stick kind of floating in air, but I did it from a point that I know, 1 3/4 over, 1 3/4 back, which are measurements on here, and then drawing up 7 1/4 inch, and then drawing that stick across. So maybe to put this in like simplest, in a very simple way, if I wanted to find a point in this chair that is kind of 6 inches backwards and 6 inches into the thing, and it's a 1 foot tall line that's like in the middle of this thing, I can measure whatever measurements I just said. Can measure on this kind of x-axis, or I guess this would be the y, 1 foot backwards on that line. I think I said 6 inches, but 1 foot backwards on that line, 1 foot in on that line, and now if I want to, that's marking that point on the ground. And now I can make a line that is 1 foot up in the sky, and it is 1 foot long. So there's a line that's kind of hovering 1 foot in, 1 foot over, and 1 foot up in the sky. It's kind of floating there. That's the basic principle of how you're going to build a lot of elements on this chair. But this is going to be your best friend. You're going to look at this a lot because you're going to always need to know how far over is it, how far back is it, and then how far up is it. And then you can start drawing stuff. So that's really all I have for this demo. I think I'll post this to YouTube. I think with that lesson alone of learning how to draw stuff kind of in midair, you'll be good to draw the whole chair. Because really this whole thing is just built with 1 3/4 inch sticks that are at different points in the sky.
Can I give them one little tip?
Yes.
How zoomed in is it that they can see? Is there any way we can zoom in a little bit more?
Yeah.
I'm gonna give y'all a tip because these are gonna be very, very precise little measurements. And my sense is when students start feeling like I'm off, screw it, and you just kind of give up.
Like that?
Here's what I would always do. Yeah, let me get a little bit darker later so y'all can see. Number one, keep you a sharp, sharp point on your lead, okay? I would just, in general, run you long line and put a point wherever you want to start. Can y'all see that tiny little dot? Put you a point where you're going to start. What I would do if you're measuring like 2 feet 1 3/4 or something, put, because you can see there's 0, there's 1, there's 1 1/2. So between 1 1/2 and 2, I'm gonna locate that little dot. Then I'm gonna go up here and I'm gonna put me a dot on 2. That's easier to do, I think, than starting with the 2 here and then trying to locate a dot in that precise point. So I always put a dot down, then I set my scale in the 1 3/4 inch location, because I can see that little dot, and I can move my scale till that dot's right in between the 1 1/2 and the 2 inch. Then down here, and if you have, I don't know if y'all have noticed this, but there's a ever so slight, like if I rub my lead, y'all hear that? There's a little slight indentation where these marks are on your ruler. And if you have a nice sharp lead, you can actually set the point of your lead in that little groove and just slide it straight down onto the paper. That helps you with your accuracy, okay? We're not, as long as you're using light construction lines, we don't really care that these lines go beyond what they need to be. So, and remember too, you can always, as you're working, you can go back and you can check your measurements to make sure it's right. It's like the old carpenters, measure twice, cut once. You know, because if you measure and cut and then you see it's wrong. But I do think that will help y'all if you'll, even like when you're doing the little 1 3/4 by 1 3/4, if you'll put you a dot down just wherever you want to start, and then locate the 1 3/4 before you then go back to the 0 and put that little, it's hard for y'all to see, but there's a little dot there and there's a little dot there. That gives me much more confidence that I'm being accurate. This is kind of a funky scale, so just go slow. Just take your time. And because I'm not a great math whiz, and I did that layout rather quickly the other day, I'm working out an actual axonometric. I know I got the plans and the elevations and all of that straight. I'm going to do an axonometric real quick just to make sure I'm showing that accurately to y'all. So I feel pretty confident, but a few of y'all have asked me questions and I've like said something stupid and y'all are like, really? And then I'm like, wait, oh, you know, it's age. Just take your time.
Take your time. Okay.
I'm gonna stop